Welcome to part 2 of the revision exercise for analytical geometry. Part 2, we are basically required to consider points which are on a Cartesian plane. Those points are A, B, C, and D, and as a result, we are required to determine the value or values of K for each of the following conditions, A until E. So 3 and 4 will make part 3 and part 4 respectively. So now let's look at part 2. We're just going to look at number 2, starting with A. If we are given the midpoint of AC and the coordinates of the midpoint are already known, how can we determine the value or the values of K? Look at this. K is just the y coordinate of C, and the midpoint, the y coordinate of the midpoint is already given to us. So if you remember, this is the formula, YA plus YC all divided by 2. So the y coordinate of the midpoint is already given, and you just need to substitute the y coordinate of C, which is of A and C. So of A it's actually 2, and then of C, that is K, all divided by 2. Then this is, from here you can just simply solve for K. K is equals to 4, as you can see. That is it. And then suppose now what they are saying with B, what is happening is that AB is parallel to CD. So just pause a bit, try to copy the points, then because I'm going to move the screen and you're not going to be able to see the question. So yeah, with B, if AB is parallel to CD, what is happening is that the gradient of AB is equals to the gradient of CD. Okay, and then if they are equal, what you can do with this is the fact that you can calculate the gradient of AB like this. Minus divided by XB minus XA equals to YC minus YD all divided by XC minus XD. Then we just substitute all the points. This is 1 minus 2 divided by 3 minus 1 equals to K minus negative 3 divided by negative 3 minus 2, like that. Then when you simplify, we get this. This is negative 1 over 2. Then just solve for K here. Let's just multiply, or cross multiply rather. When you cross multiply, what we can do, you'll have something like this. Okay, and then as a result, K is equals to negative 1 over 2. But from here, however you simplify, just make sure you get K as that. That's fine. I hope you know how to simplify. If you're having problems with simplifying, you can always ask. We'll assist you. It's fine. Okay, C, we are given the fact that AB is perpendicular to CD. If that is the case, then we know for sure that for perpendicular lines, the product of their gradients is actually negative 1. That doesn't change. And then we already have the gradient of AB. We did calculate it from here. Negative 1 over 2, that's the gradient of AB. I hope you see that. This is that gradient. So from there, we can just substitute it here. Negative 1 over 2. We don't need to calculate it again. So, and the gradient of CD, what is it? We have tried to simplify it a bit. We got this. So we can just substitute that. That is K plus 3 over negative 5. K plus 3 over negative 5 equals to negative 1. Just like that. So from here, we just need to then simplify and solve for K. How do we do that? This is C. To do that, it is quite, is it tricky or what? Nah, it's not tricky. K plus 3, 2 times 5 is 10. I took negative 2 and 5, that gave me 10. Okay, negative 2 and negative 5. That's why the negative signs, they cancel and they made it a positive there. And therefore, we have K plus 3 equals to negative 10. As a result, K is actually equals to negative 13. I hope you're fine with simplifying. And then let's look at D. With D, we are being told that A, B, and C are collinear. Remember what I told you, or what we discovered when we were going through the revision of the content, is that when A, B, and C are collinear, that means the gradient of AB is equals to the gradient of BC, and that is also equals to the gradient of AC, just like that. So we already know the gradient of AB, that is negative 1 over 2. We don't need to calculate it again. And BC, because we don't have C, we couldn't really calculate the gradient. But the furthest we could go, did we try? No, we haven't. So we'll just do this. YB minus YC all divided by XB minus XC. Okay, negative 1 over 2, like that, equals to, what is YB? YB is actually 1, and we're going to put 1. XB is 3, like that. YC, that is K, and then XC is negative 3. Okay, just gonna do that, substitute, and then we keep moving. Negative 1 over 2 equals to 1 minus k, all divided by 3 plus 3, which is 6. And then we take 6 times negative 1 over 2, that is negative 3, equals to 1 minus k. As a result, we can say k equals to 4. I hope you see that. Okay. And E, I think that's the last one. We are given the distance of CD. So if we're given the distance rather of CD, we are going to use the distance formula. CD is actually equals to the square root of x what? Let me just do them in the order that I've already done it, so that I don't have to do a lot of unnecessary work. YC minus YD all squared, like that, the square root of that. So just substitute. This is 5 root 2 already given to us, and what is going to be our CD coordinates. So let's just substitute negative 3 minus 2 all squared plus k minus negative 3 all squared. Take the square root of everything, and then you can already see this thing of the square root is not going to be interesting for us, so we need to get rid of that square root. To get rid of the square root, we just take the square of both sides, because this square root thing is just going to distract us. So when you take the square of the left hand side, rather, you get 50. You can just punch that thing on the calculator. No one said you shouldn't use the calculator at this point. I get it. And then minus 3 minus 2, that is minus 5. You square that, you get 25. And then plus k minus 3, that's k plus 3, all squared like that. So now we're just going to simplify. 50 and this 25, we can just have one of the 25s that side, k plus 3, and then k plus 3 like that. 50 minus 25, you remain with 25, that's why I have that. K squared plus 6k plus 3 times 3, which is 9. I hope simplifying is not that much of a problem for you. So we're going to have k squared plus 6k, 9 minus 25, that is negative 16. So when we have this, you can just flip this thing and write it like we like to say it, like this, with 0 on the right. I think that's what we are used to. And then at this point, you can either use the quadratic formula or act as if you know the factors, even though you still use the quadratic formula, or explicitly show that you use the quadratic formula. It's definitely up to you. So me, I acted as if I know the factors, but I got them from the quadratic formula. Okay. Yeah, so that is you having simplified, then you are done. So here you have